Hello everyone, I hope you're well. This week's maths is going to involve lots more on angles. So we're going to start today on vertically opposite angles, and I actually want you to watch a different video that's very helpful in its explanation, but I just thought I'd start you off with a short clip first because there are some words in the video that I'm not sure that you'll understand, so I'm going to clear those up and just do a demonstration. So I've got my notepad here which I'm about to use. I'm going to have to move my camera, which is quite a tricky thing to do, so bear with me. So let's just move this now, and hopefully you will be able to see my paper. Perfect. Okay, let's just straighten that up. There we go. Camera never likes to be fully straight. So you can see here that I have drawn myself 3 circles, and I've got a line intersecting those circles. So the word intersecting just means to cut across, to cut through, and that's what they're doing. They're going exactly halfway through my circles. So in order for us to be able to calculate vertically opposite angles, we need to know how many degrees are in each circle. So I'm pretty confident that you all know the answer to that, and I'm hoping that you're saying that in your head as I write this now. So the answer is 360 degrees in a circle. So if you know that, and you know that I have intersected, cut through my circle of 360 degrees perfectly in half, then you will know the size of angle for each of these 2 semicircles. So just think in your head for a second, and you should have got 180 degrees for each one. Perfect. So what we're saying here, when we're working out vertically opposite angles, we're saying, so vertical means to go up, horizontal is the opposite, that goes across like I've got here. So these vertically opposite angles are equal. Equal obviously means the same. So we're going to have a look at different ways we can work out vertically opposite angles. So this is a really straightforward one, and I've got a straight line cutting through. That straight line is really important in this. Let's have a look over here. So we know that this circle is also going to have 360 degrees. So I've got 2 equal angles of 180 at the top and the bottom. So what I'm going to do now is I'm going to cut through my circle. I'm going to intersect again. It's really important that my straight line meets that centre point in my circle. So I can't do a straight line on the edge of my circle there or there or there. I need my straight line to meet the centre of my circle. So I'm just going to draw a straight line here. I've just slightly missed my centre point there, but let's pretend I did it perfectly. And what we're going to say now is, knowing what we know about vertically opposite angles, they should always be equal. So I've got, let's label these, I've got A, B, C and D. So if my thinking is correct, A and B should be equal, and I'm going to do that. I'm going to test it by using a protractor to measure. And in the video you're about to watch, you will notice that they say the word origin, and you might not know what that means. So the origin of your protractor is this central part here where the vertical and the horizontal line meet. So you've got that perfect point in the centre of that semicircle there. So that's your origin, and what we want is for the origin to meet up with the centre of that circle and line up perfectly with your straight line. So now that I've done that, I can measure my angle. So I'm going to start on the outside of my protractor at 0, which is where my line starts, and I'm going to follow it all the way around the outside to where my point stops, and it looks like I've drawn an angle there. So we've just gone past the 120. I'm just going to get that camera a bit closer so you can see. I've just gone past 120, and it looks like I'm about 125 there. So that's where my point was. So I know that A from here to here, so this whole space here, equals 125. degrees. So if I'm saying that vertically opposite angles, so A and B are vertically opposite, are equal, then B should equal 125 too. And what I'm going to do here is flip my protractor round, because I'm measuring the angle on the bottom of that line. I'm going to put my origin in the centre of the circle like I did before. So the origin is there. Can you see that I'm matching it up with the centre of my circle? And I'm going to line up that bottom straight line with my straight line. And my angle for B goes around here. So I'm going to start at 0 and follow it round until I can find, oh, I haven't lined that up just perfectly, there we go. I'm going to follow it round all the way to where the line is, and we've got 125. Lovely, so that shows that our vertically opposite angles are equal. So if I know that A equals 125 and B equals 125 degrees, so I know that A plus B equals 250. Let's do that. A plus B equals 2, I'm doing this slightly upside down, so you might wonder why my handwriting's a bit funny, equals 250 degrees. Now I know that in my whole circle I've got 360, so if I subtract 250 from 360, that leaves me with 110. So if I know I've got 110 degrees remaining to split between two equal angles, how much can you predict that C and D equal? I want you to do that in your head as I just show you. Oh, my pen's run out. There we go. So you've got your two vertically opposite angles there, C and D, and you've got 120 degrees to share between them. So you should have got 55 degrees for each one, and that's how it works. So I'm going to show you one more example of how not to measure vertically opposite angles. So we've got a final circle here, and notice how I mentioned on this one previously how important it was to have a straight line. If we're going to measure vertically opposite angles and say that they are equal, it has to be a straight line. So what I'm going to do on this one, I'm just going to make my centre point of the circle nice and clear for you to see. I'm going to draw, let's do it this way this time. I'm going to match up my ruler to the centre point. So I've drawn part of a straight line there. Oh, the light's not very good there. I think the sun's just come through the window. Hopefully you can see that. I've got a straight line there. If I carried on down my ruler, then I would have equal angles that were vertically opposite. But what I'm going to do now is I'm not going to make it straight. I'm going to tilt my ruler, and I'm going to do a different angle up to the centre point of my circle. So you can see, oh, do you know what? I'm going to try and sort out that light that's coming through. There we go, that's better. So we're going to test this now using the protractor to see if the vertically opposite angles are equal. So let's call this angle here A, this angle here B. So we should know how to measure the angle for A. I'm going to put the origin onto the centre of the circle, line up my straight line at the bottom with my straight line, and I'm going to go from 0 all the way to where the line for A stops, and it looks like it's pretty spot on 60 degrees there. Okay, so A equals 60 degrees. Now let's measure B. So I'm going to flip my protractor around this way. Going to line up my origin and my straight line at the bottom, and the angle for B starts here at 0 and it goes all the way round. I can see it stops there, so it looks like B is pretty much spot on 80 degrees. So B equals 80 degrees. So you can see that those two angles are in fact not equal. and the reason for that is because I didn't draw a straight line. If I'd drawn a straight line, it would have cut through, intersected about there, but I tilted it, so I've made the angle for B bigger. So that's pretty much it. I hope that made sense, and I want you to watch the video that your teachers will be able to find for you. If you're in school, your teachers will be able to find it for you. If you're at home, it's the week 7 video for day 1, which on the website you'll be able to find the link to this on the daily learning plan, but on the website I think that's week 3. So give it a go, and if you've got any questions, send them through to me.